Wow, on yesterday's Daily Space Weather video, I believe I stated that the story of the day is filaments, and we specifically talked about and showed close-ups of that filament right there, the one that is currently ejecting as we make the video. We'll show you that and lots more on today's Daily Space Weather video. And thanks for tuning in to the Smash News Network, least busted name in news. Let's show the full disk view here for a minute because, well, it's pretty sweet. This is 24 hours of SDO, 304 plus 193 angstroms. And I would attract your attention to the lower right, the southwestern limb. An epic proportioned solar filament there is in the process of ejecting. It's been going on for hours. It's not likely to be earthly directed, just an exciting fireworks show. So there you go. We may have to make some more videos today just about that. You can also see some activity there in the southeastern limb. First, let's cut back to this close-up. That filament, whoops, no longer anchored. Most of it looks like it is on its way out. So here's sort of the equatorial view. We've got a couple sunspots that never got a name yesterday. They'll get a name today. We'll talk all about it. It's this sunspot right here and this one that's just risen. So this one down here, by the way, is now probably the most likely place to see large solar flares. So that's something to consider. Also, we've got a huge filament or two hanging out up here around the northern polar region. Also a coronal hole that we're waiting to close up. Here's a close-up of that huge North Polar filament once again. We showed it yesterday. Here it is again today, making the rounds. Great stuff and stellar imagery indeed, and thanks for stargazing with us. So before we continue on, we'll get to the rest of your space weather and Earth weather together. Please take a moment to support the channel. Press the like button, subscribe, press the notification bell, etc. Visit our website, smashomash.com, and welcome to the Neo-Renaissance. Congratulations on realizing that our channel exists. We've been producing the most detailed space weather and comprehensive solar imagery you'll find in the known universe. And it is nonsense-free. These videos are designed not to offend Eugene Bagashov, Dr. Tamitha Skov, or Dr. Pierre-Marie Robitaille. So, smashomash.com is our homepage. There is a paid affiliate link. This does include a paid affiliate promotion. One of those is Hemp Lucid. So if you are in the market for some CBD tinctures, for example, don't forget to enter the promo code SMASHOMASH on checkout and save 10%. There's a link below the video in the description to the CBD shop, so you can use that link, or again, you can use the promo code SMASHOMASH to save dough on checkout. So check out the splentacular products there from Hemp Lucid. You can even find some information about the products on our product reviews playlist. And if you're viewing on BitChute, go subscribe over on YouTube. You're missing like 98% of our content. Tons of different products there for all sorts of different things, whether it's for sleep, immune boost, or just anti-inflammation. Boost your performance, perhaps with some Hemp Lucid products. You can also find some more products to boost your performance. If you want to know what supplements I take, I became a pro cyclist back in 1999 on the cross-country mountain bike scene. If you want to know about supplements, you can find them on the Amazon shop. Today's featured product is not Do the Math. Today's featured product is our bestseller, which is available also via links below this video. And is there still a site-wide sale? 20% off of everything at the site at Redbubble. You can find links on the homepage as well to the Redbubble shop. The Smasho merch link. There's also a graphical link on the homepage and a link below this video to the Redbubble shop. So check out the merch. And whatever you do, no matter how bad things get, Please do not pole vault the caldera. If you are on if you're going on a volcanic vacation, leave that vault pole at home. Beef up your summer wardrobe and start a conversation about people doing dumb things, perhaps. It's a public service message at massive personal risk and expense by Smash staff and I. You can also support the channel via subscription services at smashomash.com/Smash Team. So that's the official subscription services site. Become a silver Smash Team member for $2.99 a month, a gold Smash Team member for $9.99 a month, and get additional content. There's also a bronze level. We do send out email alerts, etc., about all kinds of space weather events, tsunamis, and more. From smashomash.com/Smash Team, launched back in October of 21 to increase our capabilities. So here we are looking at SDO Continuum for yesterday plus today. Let's see. Any major changes with sunspots? Not so much. Mostly stable there. Again, we do have two more groups that we're expecting to get names today. The one was just rising yesterday. Keep in mind they do have to be on the Earth-facing portion of the solar disk for more than 12 hours to get named. Here's the colorized magnetogram for the same time frame. That is June 3rd plus June 4th to date. Next, we'll take a brief look to see what's going on Croissant Earth. Yeah, Earth. It's croissant-shaped. Join the Croissant Earth Society via our merch links as well. These are the volcanoes currently erupting. Suwanosejima producing a 6,000-foot ash plume. Popocatépetl producing a 22,000-foot ash plume. Flight level 220. Flight level 210 over Colombia from Nevado del Ruiz. Flight level 200 over Sangay in Ecuador. Two other volcanoes erupting there as well. Revenador exploding. No indication on the size of the ash plume there. Don't fly your hang glider or ultralight aircraft over Revenador. Also, Cotopaxi exploding, flight level 220, flight level 220 over Sabancaya in Peru as well. So that's the earthquake rundown. The volcano rundown. Here's the earthquake rundown. And we did have quite a few earthquakes in Alaska over the past 24 hours. Let's check out the list here. We'll report specifically quakes over a 5 magnitude. Just keep in mind any earthquake can be a foreshock. So a little swarm there on the west coast of South America, in the southwestern Pacific, and the northeastern Pacific there. Again, Alaska seeing a series of quakes. And drop us a line if you felt an earthquake in the past 24 hours. We're always interested in that. But keep in mind, folks, we do read all comments. Although we are not able to respond to every comment, we do read them all. So drop us a line. Tell us where you're located if you are new to the channel or old to the channel and have never left a comment. So here's our first 5+ magnitude quake. Once again, Somalia continues to shake there. That's a 5.4 at 13:58 Universal Time yesterday afternoon. Quite a few quakes in the U.S. there as well. One just came in while we were producing the show. There was also a 5.2 at Indonesia. That was just after midnight there, 25 minutes after midnight at 0:25. Tonga had a 5.3. That was at 3:16 this morning. Indonesia had a 5.0 at 5:52 this morning. And check it out, a 3.2 just struck West Canton, North Carolina. Drop us a line if you felt that quake. And let's get back to space. So here's some more SDO imagery for you. That's 171 plus 131 angstroms. And that is a 24-hour SDO video there. Check it out. My shirt is all full of space. Yeah, all full of space, folks. Here we've dropped the 131 angstroms to show just 171. And a quick note that we've got significant possibility of large solar flares, especially at both limbs, both the eastern and western limb. I would say the most likely place to see a large flare would be down here, as this new sunspot that just rose down here is quite magnetically complex. It does show the sort of magnetic shear that we would expect to see producing a large solar flare or associated with a large solar flare. Here's the equatorial view in 171 angstroms in all of its lower chromospheric filamentary glory. 171 angstroms is a specific species of ionized iron, and that is part of the extreme ultraviolet electromagnetic spectrum. A type of photons that are at too high of a frequency to be detected by the human eye or even on the ground, as that is filtered out by the time you reach the mesosphere. The thermosphere filters out this portion of the electromagnetic spectrum. There's that eastern limb. Again, the southeast down there in the lower left is, in my opinion, the most likely place to see a large flare today, and the probability is kind of high. And let's cut to our solar data here. So 10.7 centimeter radial flux is now at 165 solar flux units. There is the 1 year graph. To put it in context, the black line is the radial flux, the red line is the sunspot number. You may note how proportional the red and black lines are. The radial flux and the sunspot number are the chief indicators of solar cycle activity. And here's a space weather enthusiast dashboard, not forecasting any sort of geomagnetic storms or anything like that. I would tend to agree it's clear sailing out there in space. Not a lot of space weather headed Earth's way at the moment. Keep in mind that can change rather suddenly with basically no warning. And something funky's going on here. Space Weather Prediction Center this morning has been showing some issues. So I don't think we're going to be able to show you. Oh, okay, it came back. So here's our geospace magnetosphere movie. Let me get off screen and bring that back. This is the past 4 hours of Earth's magnetic moment from space. It depicts magnetohydrodynamic pressure, the units of which are nanopascals. And okay, that was interesting. Well, at least it played part of it. Now it's refusing to play. Here's Earth's magnetic moment from the ground for the past 4 hours, we hope. By the way, there's not a lot of data to miss there. It's geomagnetically calm conditions. One of the reasons we show this data every day is because people are convinced that Earth's magnetic poles are going to flip, a truly ridiculous notion, and if it requires a grand solar minimum, abandon that theory. It's idiotic. That's the past 4 hours of Earth's magnetic moment from the ground, and the KP index is currently at 2.33. Yeah, 2.33. It's a geomagnetically calm situation. Next, we'll see what's going on with the real-time solar wind. And we did see an uptick here. So here's a coronal hole wind stream finally showing up. We've seen the solar wind density finally come up to just under 24 protons per cubic centimeter. You can expect to see this continue to drop off here and the solar wind speed to come up to like maybe 600 or 700 kilometers a second. Current conditions are only 346 kilometers per second for the solar wind velocity. Solar wind density now down to 11.74 following that recent peak of like 25 protons per cubic centimeter. I would also note that the magnetic field has shifted into positive territory, a situation unlikely to create geomagnetic storm conditions. But when the high-speed portion of the coronal hole wind stream does arrive, that could all change. So that's something that we'll be monitoring throughout the day, and we'll keep you posted on any changes and send out emails and so on to the SMASH team if we are expecting significant geomagnetic storm or unrest conditions. Next are GOES magnetometers there, and you can see a little bit of a variation happening there around midnight local time for the GOES 18, which is what that blue M on the upper right stands for. That's midnight local time for the GOES 18. So a little bit of a divergence and a spike in the GOES 16's magnetometer reading there around that moment. Next, the heliospheric current sheet, and this is super important data in that it's showing us the solar cycle progression. So, shout out to one of our, perhaps our largest contributor ever, Mr. Katowski. He asked us about this yesterday, and what we're watching here is we're watching the north coronal hole, the North Pole-oriented coronal hole leaving the North Heliographic polar region. That needs to make it all the way to the south before we reach solar cycle 25 to 26 transition minimum. And before we reach maximum, it pretty much has to leave the North Pole as well. So you can see it looking like it's wanting to snap down toward the equator more. And that is one of the most important features, if not the most important feature, for the progression of solar cycle 25. And it's going to be off to the races once that coronal hole leaves the north heliographic pole. Anyway, there's the latest image. That's the top view ecliptic plane field plot. Earth right in the middle of a North Pole current sheet depicted here in green. That's the North Pole heliospheric current sheet. Here's the southern polar heliospheric current sheet. The plasma that comes out of the sun is polarized to one of the sun's magnetic poles. Again, Earth is in a North Pole current sheet. Here's our line of sight plot. And you can see how fanned out that blue portion looks. That is the solar B field. Again, you're right in the middle of the north magnetic pole of the solar system at the moment. And next we'll move to coronal holes. Coronal holes are super important in that they show us the solar polar field reversal process associated with each solar cycle. So you can see this. Once again, now we're looking at a different view, the line of sight coronal hole plot, and you can see this coronal hole right here. This is the one to watch, folks. That coronal hole right there. When that starts making its way down toward the equator, we'll declare that it's solar maximum, and you can expect to see a huge increase in solar activity there. These forecasts are based on lots and lots of statistical data. The likelihood of those being incorrect is incredibly low. So that's our line of sight coronal hole plot. And let's take a look at some coronal holes in SDO wavelengths. So here is this is SDO. We put 335 plus 211 angstroms there. And let's subtract the 335 angstroms. That's the blue portion. That's what makes it look purple. It'll look a little bit more rose-colored here at just 211 angstroms. And again, eyes on this coronal hole up here. That one is going to be making its way south. In the next, I don't know, few months, it can move quite suddenly. It could lurch. And, yeah. Those are all North Pole-oriented coronal holes here, by the way. That's North Pole, North Pole, North Pole, North, and that one up there is also North. So the Earth right in the center of the North magnetic solar system pole at the moment. Let's take a look at some sunspot information. Here's the current situation for solar flare probability and sunspots. So there is a sunspot right here. That'll be 3327, and this one down here will be 3328. You can see there is a rather high likelihood of flares from this group here, according to the flare monitor. I would say this group down here is actually the most likely. It is changing numbers there because they are like sequentially numbered. But this group down here in the southeast, in my opinion, is the most likely place to see a large flare. Continuing on to here's an SDO magnetogram for the past 24 hours. Again, not a lot of evolution. Sunspots here are not really growing or degrading. They're mostly stable here, and you can see by the magnetic fields, not a lot of motion happening there. So quite a few sunspots on the Earth-facing portion of the solar disk. Here's SDO continuum. Another 24-hour video. So only minor evolution there. This group up here has degraded and almost completely evaporated. Besides that, not a lot of changes happening. And let's talk energetic particles and solar flares. As far as energetic particles, we ain't got none. As far as solar flares, it's been pretty minor. So here's the GOES proton flux, which, as you can see, contains no solar energetic particle events. And there's the X-ray flux. There was one decent flare here, almost an M class. kind of a long duration there, a little bit flat on the top. It was a C8.89. Looks like it was about the peak flux of that one. And let's see if we can figure out where it came from. I've got ideas. Here is 94 angstroms to help verify those. And I think it might have come from this group down here, actually. Anyway, that's 94 angstroms for the past 24 hours. And of course, if I say something wrong during the videos, please correct me in the comments. Some of us who do actual science like being wrong because it leads to learning. Yeah, learning. Anyway, we're not wrong very often with our forecasts on the channel, as you may have noticed. Here's the past 24 hours in 131 angstroms. Pretty sure that C8.89 flare came from this group down here. I'm not changing my mind. This is still the most likely place to see a large flare at the moment. We can see lots of plasma activity down there, including coronal mass ejections. And let's take a moment to step back and remind our viewers to look up. If you want to know what's going on overhead, try skyandtelescope.org's star chart. This is what's going on over Lehigh Valley, Pennsylvania at the moment. Press the Now button to get the most recent update. It's a little chilly. We'll get to the meteorological information. Dear Mike, stop sending cold air from Canada to Pennsylvania. It went down into the 40s last night here. Anyway, that's your star chart. That's what's going on at the moment over Lehigh Valley. Again, skyandtelescope.org is what we use for that. This is theplanetstoday.com. As we like to orient our viewers before we talk about coronal mass ejection. So here's where stuff is. Stuff meaning heavenly bodies in the solar system. Here's where things will be in a week on June 11th. And let's move to coronal mass ejections. So here are yesterday's coronagraphs. You can certainly see an interesting filamentary ejection there happening in the southeast. A long string of plasma there. So another example of the different types of shapes that coronal mass ejections can take. Sometimes they're like a cloud with a core. Sometimes they're like a hollow cloud. Sometimes they're like a series of sheets or a series of filaments. And this imagery helps us to forecast what they'll do when they do arrive at Earth. None of these appear to be directed in that fashion. That's yesterday's coronagraphs. Here are today's coronagraphs, an additional 35 frames. And this should be a pretty hot topic today, as there is an incredibly massive CME erupting from the southwestern limb as we speak. So here are the Soho-Lascaux coronagraphs. And right at the end, you should just see a little bit of brightening down there in the lower right. I'm going to let that play through one more time here. Looks like multiple events going on there around the same time. We'll also show stereo A and Soho-Lascaux C3. Here's stereo A on the left. And we show this diagram because stereo A is overtaking the Earth, and the Earth is overtaking stereo B. It's not giving us very good angular views of coronal mass ejections, but it does provide some additional data in that sometimes there'll be missing data from one of the coronagraphs, and it helps to have the data from the others. Just keep in mind that those are not synced. There you can see that filamentary eruption there happening early yesterday. And what's next, you ask? Filaments. We talked about filaments yesterday. I think I started the video by saying that filaments are the story of the day. And you're going to hear a lot about this filament. Nobody ever named it. We suggested it get a name I don't think anybody ever named it. By the way, if you want to name filaments after living people, follow the hashtag #NameThatFilament. Hashtag #NameThatFilament over on Twitter. And this filament is, whoops, no longer nameable after a living person, as it is now flying through the solar system, probably at great speeds. So that's El Teide, Spain's ground-based hydrogen alpha telescope. Additional honorable mention filaments are this one up here that we showed a close-up of, and this one down here, south of that active sunspot region. Let's take a look at that CME as it continues to propagate. So this is the past couple of hours. Oh wow, a huge portion of that looks like it's crashing back down toward the chromosphere. So right up here north of that filament, you can see some of that plasma there is now making its way back down. So you should see a brightening there. That'll produce a specific type of flare, and then you can see that huge amount of plasma there on its way out. So a lot of that plasma is not actually ejecting, but a massive plasma reorientation happening there. I'm not going to try to estimate the mass of that. It's a lot of mass. So there's some fresh imagery for you, I'd say. It's the GOES 18 SUVI for the past like 2.5 hours. And you'll see people talking about this all day today. Somebody will probably get in their bunker as a result of seeing that. Last but not least, we've got the last 24 hours from SDO. In the same wavelength, 304 angstroms. You can see that CME beginning. And it's not just a CME, it's a coronal mass ejection and a plasma reorientation event. Also another one happening over here. That was that filamentary eruption from yesterday, sort of the tail end of it. Also, you can see another CME coming out down here, or maybe just another plasma reorientation. Anyway, this space weather station is now moving to our bonus features coverage. So the first thing we'll look at is satellite charging hazards. At the moment, according to the satellite's community dashboard, only some minor surface charging hazards are occurring at the moment. They are in the East Pacific, caused by low-energy electrons building up on the outside of satellites. Those surface charging hazards are minor. The GOES electron flux here, as measured using radiography from the geosynchronous orbits of the GOES 16 and GOES 18 there, showing a little cratering there of the GOES electron flux, and that is a thing that we typically see with coronal hole high-speed streams. Again, expect the coronal hole high-speed portion to arrive any moment. Expect the density to continue to drop off and the speed to come way up. So I think we reported the speed was only at 345 kilometers a second. Expect it to go to like 600 plus kilometers per second. And here is the relativistic electrons over the past year. Another one-year chart there from Solon.info. That'll be updated later today, I suspect, with lower numbers. And there's the forecast model. We can expect to see this down here for today's update when that comes through. That's NOAA's forecast for the relativistic electrons. And next we'll show the F layer of the ionosphere. And feel free to pause the video on this frame. This is a very important frame, folks, because this frame, it not only shows the different temperatures of the different layers of the atmosphere, like how the troposphere is warm at the surface and cold at the stratopause and so on. The middle portion is depicting the penetration of electromagnetic radiation through atmospheric layers. As you can see, only visible and infrared light make it all the way down to the ground. Also, near UV makes it into the troposphere. But then, extreme UV doesn't even make it to the mesosphere, and the X-rays never make it to the stratosphere, and so on. This is why we use spacecraft to show these data sets, because many of them are non-existent at the surface level. So feel free to pause the frame on this portion if you're not familiar with these things. And here is the ionosphere map, courtesy of Australian Government Bureau of Meteorology. We are seeing some significant ionospheric anomalies once again here today. So, I mean, the GOES magnetometers and the electron flux are all giving us indications that indeed there is some corroborative data there showing that there's some activity. It's a coronal hole high-speed stream impact. Again, expect the density to drop and the velocity to increase for the solar wind speed. Let's show the anomaly gram here as well. Looks like a lot of low-frequency anomalies here. So here is your anomaly from the 30-day median map. It depicts low-frequency anomaly in red, high-frequency anomaly in blue. And this is a great way to watch the ionosphere evolve throughout the seasons. Of course, we're getting into a less geomagnetically active time of year, as the solstices are less geomagnetically active than the equinoxes because of the Russell-McFerrin effect. Yeah, the Russell-McFerrin effect. It has to do with the acceleration of relativistic electrons in the outer Van Allen belt. Anyway, this is the... Let's get the latest image here. There's the latest image, 11:15 universal time ionogram and 11:15 universal time anomalygram. Total electron content is free electrons up to about 12,500 miles of altitude. And feel free to pause the video on this frame if you like my shirt. By the way, you can buy this shirt at the Amazon shop, amazon.com/shop/smashomash. But feel free to pause the video on this frame if you're not familiar with distances to these things in miles. Here is the total electron content forecast. And you can expect some added GPS errors throughout the coronal hole high-speed stream. It could last a day or two. I suspect it'll probably last something like 18 to 24 hours. That is our coupled thermosphere, ionosphere, plasmasphere electrodynamics model. The total electron content, the most likely places for GPS errors. Here's a total electron content anomaly from the 10-day average over North America. And we are indeed seeing some high electron content anomalies there over Mexico especially. And it looks like we never saw the major earthquake. We were looking at the possibility of a large earthquake of a 6+ magnitude somewhere around the Caribbean, Mexico, or Central America because of total electron content numbers, but we never really saw that. So yet another time that these claims of being able to forecast earthquakes because of space weather data not really panning out, but hey, it's possible. It's probably a signal coming from the Earth side, not the space side. An indication that, space weather isn't necessarily causing earthquakes, but could be correlated with it, or at least the data sets are correlated with it. And I'm going to wade back out of the weeds now and show the latest high-res imagery. So once again, it is also likely to see a large solar flare from down here, because that's a pretty magnetically complex sunspot group as well. It is beta gamma delta class barely. This group over here, no, it's actually not that magnetically complex. That's interesting. So that one does have a leading South Pole umbra. And it has a couple of trailing North Pole umbrae. That's beta gamma delta class as well. All right, well, I stand corrected. This sunspot here remains the most likely sunspot for a large flare. It is big. It's got a lot of magnetic shear. In other words, you've got a North Pole umbra right here, and then you've got a strong South Pole umbra right there. Back here you've got North Pole magnetism mixed in close to these South Pole leading umbrae. Those are the kind of things that lead to large solar flares, or that are associated with large solar flares, I guess I'll say. Anyway, here's the full disk. Again, the most likely places to see large flares would be here, down here, and here. And it's time to say goodbye to space weather and head to Earth weather. The first thing we're doing is some wave chasing here at the Smash News Network, least busted name in news, as I am a wave enthusiast. Yeah, I like high seas. I like high seas and blizzards and 100-degree days and days with 8-degree high temperatures as well. I like all the extremes, folks. I like all the extremes. The world's largest waves, the oceans are calm right now, folks. And the world's largest waves are only like 27-footers in the Southern Ocean. There you go. That's the surface wind scenario and the significant wave height. So it looks like no waves over a 30-foot at the moment. The seas are pretty calm. Maybe it's a good day for Viking raids. Let us know if you're rowing a longboat across the North Sea. And of course, drop us a line on YouTube or Instagram or Twitter. We'll be more than happy to feature your open-top boats full of guys wearing hide armor. By the way, the Vikings did not wear horned helmets, if you're wondering. Anyway, let's do meteorology. These, like sands through the hourglass of time, are the surface winds of your lives. Strong low here off the east coast of the Kamchatka Peninsula. Here are the jet streams of this side of the planet. We've got a huge jet stream divergence here on the western portion of Australia. Here are the jet streams of the Western world. And the jet stream's getting a little bit more coherent over the U.S. We still have a strong upper-level anticyclone here rotating counterclockwise over south-central Canada. That's the jet stream scenario for this side of the planet. There is the surface wind scenario for this side of the planet, and strong winds on both the east and west coast of the U.S. at the moment, and a strong low off the west coast of Argentina. Here are the surface winds of the central world. And shout out to our viewers from all around the planet. Who knew we'd make so many pals by putting out basic facts? Facts. They're super controversial. And once again, congratulations on realizing the channel exists. There are the jet streams of the central world. And here's a pressure map. If you want to know where the world's lowest pressure is, well, it's probably either in the Southern Ocean. It's not going to get much lower than that. That's 966 hectopascals. The Southern Ocean has got the lowest pressure and the biggest waves. That's a mean sea level pressure map there from windy.com. And here is your clouds and fog map for the Americas. That strong low certainly siphoning in some Pacific weather there to western South America. Also some rapid cloud nucleation happening there around the equatorial cloud bands. That is shortwave radiation, depicting clouds and fog when it's too dark for the visible satellite. There is our weather.gov map. If your location is lit, click your location. We've got a lot of hydrologic outlook, I think. Those light green areas, coastal flood advisories there. Again, if your location is illuminated on the map, head to weather.gov. There are too many weather warnings for us to cover here on the channel. So let's move on to some forecasts. So first of all, here is your temperature anomaly forecast, partially because we're getting such cold weather. Some cold air blowing in there from eastern Canada into the mid-Atlantic states. We're located right here in Lehigh Valley, Pennsylvania, by the way. One of the biggest and best cycling communities in the world. If you're thinking of going on a cycling vacation, join us in the Lehigh Valley. Perhaps you could even ride with me, depending on what it is you're looking to do. That's your 72-hour GFS temperature anomaly forecast. We're going to have higher than normal temperatures in the northwest and lower than normal temperatures in the rest of the country. Some areas there featuring temperatures of 16 degrees Celsius below normal there. Those are degrees Celsius on that map. Next, the jet stream. It's been incoherent, and it's going to stay incoherent for the next 3 days, according to the GFS model. That is the 250 millibar wind speed. Jet stream remaining a bit broken up over the U.S. So this will continue odd weather patterns, folks. And once again, let me reiterate that it's not HARP, it's not chemtrails, it's not geoengineering, it's the jet stream. Mankind does not control the jet stream. The idea that mankind controls the weather and the climate is the pinnacle of modern ignorance and arrogance. Here's your 72-hour GFS pressure and precipitation forecast. And we'll also show total accumulated precipitation in inches. So that's pressure and precip. Here is total accumulated precip in inches. Let's take a look at lightning next. And remember, folks, lightning indeed strikes twice. Don't assume that because lightning struck a place that it's not going to strike it again. What if there's a gigantic magnetite deposit in the ground where the lightning struck? Right? Don't stand there. So that's the past about 10 hours. And let's take a look at the current situation. Do we have any terrestrial strikes in the U.S.? I'm unconvinced. Some around the Bahamas. Oh, indeed, there is some activity there in both Texas and Oklahoma. A little thunderstorm here southwest of Kylene. So a little bit of activity there. And is it still stormy north of the Mediterranean? It sure is. Just lightning after lightning after lightning there. Next time you hear thunder, check it out. lightningmaps.org. So here's the lower 48. Here's the full 50 state view. There's a lower 48 Doppler radar. Clouds and fog. And the water vapor map. Again, you can see how incoherent the jet stream is. Normally, folks, weather systems, they just pretty consistently, they just move west to east. At the moment, you can see that that is not what's happening at all, and that is because of the jet stream. If you think that is because of chemtrails or geoengineering or HARP or something like that, take Physics 1 and maybe Physics 2 and maybe meteorology also, because that is not how things work. Last but not least, it's the recap to close out this space weather and Earth weather together video. U.S. Doppler radar. Clouds and fog, featuring systems moving in odd directions because of an incoherent jet stream. And there's the water vapor map. That should clear things up. Once again, moisture getting sandwiched here in between air masses. You've got relative high pressure here, providing an impulse to this moisture here, which is a relative low pressure. And then you have a blocking system right here that's going to constrain that moisture, as well as force precipitation as huge pressure gradients grow. Anyway, thanks for tuning into the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. We're frankly surprised that you've realized the channel exists. So in the meantime, press that like button, subscribe, share, etc. We'll see you soon. And while I'm in the bunker, may that solar wind be at your back. And don't worry, my bunker is the exact right depth. See ya. Whoa!